Thank you, Ivan. It's such a pleasure to be part of this distinguished group of speakers and panel members and guests for this conference. I've really enjoyed the discussion over the last couple of days, and my colleague Mike and I were commenting how much of the challenges, how similar they are from discipline to discipline in terms of this thing we call data integration. And so what I want to talk a little bit about today is what is that really? What is it? And something I've been struggling with, admittedly, for a long time. And how do we get there? And I'll give you a snapshot of where the USGS is and some of our thinking. And then when we get later on the panel talking about the role of government, maybe we can just free-form explore a lot of other issues. So we know, I know from the last couple of days, in this group is very aware that there are big complex challenges out there. This is a word doodle from two documents from the United Nations and the World Bank that talks about global issues. And there's a lot of big issues up there that we've been talking about over the last couple of days. The thing that I wanted to mention is that these issues are not confined to a single discipline. More than ever, we're challenged to be interdisciplinary, to have science inform policy and decision making. So we've taken this approach really seriously at the USGS. We put out in 2007 a strategic plan that orients the USGS along these societal priority lines, and we reiterate in there a document and a finding of the Academies of Science from 2004 on the compelling need to be interdisciplinary in our time. If you look at our history, though, in science, we've actually gone in the opposite direction. In order to advance science in our individual fields, we've specialized. And to a large extent, we've balkanized and created these pockets of information that don't allow us to be, or at least it create the challenge of being interdisciplinary at times. We've certainly seen a big commitment on the part of this administration to science and to integrating science and to open data and to big data. These are some of the quotes from the current administration. Improved approaches are needed to derive science and social value from the vast amount of data that we're now acquiring and the data that we've been acquiring for all these years. So this brings us to this pivotal point of data integration, and I would submit that the folks in this room that are doing this great work on behalf of their organizations, on behalf of the nation, are doing a fantastic service for the nation because, as E.O. Wilson said, you know, the world will hence be run by those that can synthesize the vast volumes of information that are out there. So I look at us as warriors on the cutting edge of things to come. But what is this thing called data integration? We've used it a lot over the last day and a half. In fact, there was a great example from Brian Schwartz, who was talking about the density of swine operations and integrating that with the occurrence and the outbreak of MRSA. Ann Richard was talking about integrating chemical data with biological data and how that unlocks new knowledge. Titus even informed us of how we can integrate people's favorite books with their SAT scores. And so we had some great examples of what does data integration look like, but this has really been something I've been struggling with because it's hard to get, I think Titus also said, resources are always an issue, and it's hard to get resources behind some of the things that we're talking about, metadata, infrastructure to support the kinds of things we want to do. And when you're talking to executives, policymakers, decision makers about data or architecture or infrastructure or standards, you know, you all know as well as I do, their eyes start to glaze over after a few minutes of that kind of a discussion. So I've been after this nut for a while. What does it look like? How can we communicate it? How do we know that we're making progress toward the goal? And I came up with this spectrum at one point in time through this process of things that you can do, things that everybody seems to be doing. The far left is probably the easiest. Over here, access and discovery, there was a big explosion of portals and registries and catalogs there for a while, because certainly the first step in all this is making the data that we do have accessible, findable, discoverable. But the other end of that spectrum is probably the much more difficult thing to do that people spend decades on, and that is truly agreeing on taxonomy, on schema, definitions. I think those in the biological community have done a fantastic job in examples like you know, the genome and the GenBank and so forth. That the standardization, the agreement on taxonomy has actually created the explosion of around the world of people being able to work on that and actually solve some of those, unlock those big genome challenges. But along this spectrum of things that are somewhat approachable and doable, the things that are very difficult are these other things like this rapid explosion in tools that allow us to extract data or transform it and use it. The unbelievable explosion in applications that are occurring and that allow us to visualize data in new ways that relate it to you know, geospatially is a great actually point of integration where we can take different data sets and integrate them geospatially. And certainly there's been a lot of discussion over the last couple of days about metadata and standards and the pluses and minuses there. So as an organization in USGS, we have 9,000 scientists. We're geographically distributed around the U.S., but also around the world. Every science instrument out there has data coming out the back end of it. From, you know, you put a fish scale in and genomic data starts rolling out the back to we're monitoring volcanoes and there's volcanic ash and we're getting the composition of that. It's the scale and the scope of this problem is huge, and as an organization, we've been struggling with how do we work together toward a common goal of making our data more accessible and more integratable. And these are examples of things, of projects, if you will. You can look at it as projects or efforts that need to be done from in each one of these categories, from search tools to putting web services on the back end of some of our authoritative corporate data, to enhancing our mapping efforts through 3D and 4D visualization and modeling. And so the real key for us is that in order to advance data integration at USGS, we have to be working across all of these fronts, which makes it a huge effort and really unaffordable to do it centrally. I've heard a lot of talk about, well, do you do this centrally or you do this decentrally? And I would describe our strategy at USGS as really relying on those authoritative data owners to do what they do best in terms of the collection and stewardship and curation of that data, but bringing to that effort a cohesive and organized approach to bring that data available through data integration. So this is the last time I'll talk about what is data integration, and then I'll move on to how we're getting there. But this is what I call the eye test, and I think this is a big part of our problem in this community, is if you see your project, the thing, or your area of study, your focal point that you've been on through your career, if you see that as a project that is reliant upon the data that you go out and collect and pull into your project, that's one view. The other view is if you see your project as a project that can contribute to the vast volumes of data that's out there. So if we flip it a little bit to say, okay, what I'm going to do when I collect data is I'm not going to only serve my needs, but I'm going to serve the needs of the entire community. You've got the picture here on the right, where the project is contributing to a pool of data, whereas this one, the project is collecting its own and relying on its own data. The reason why this is a big difference is, after many projects, this is the view you get from the one eye test, and this is the view that you get from the other. Is that in this integrated data view, many people participate and contribute to the data resource. The data is visible, it's indexed and accessible, it's defined, quality controlled, and all those lovely things that we like to put on data. And yet it's always continually evolving as new contributions are made. And so the question is, how do we get there? In the USGS, these top-down approaches have not worked that well. You know, we're going to build a big database in the sky. First of all, that's very resource intensive. Secondly, it's somewhat threatening to go out there and say, okay, you're not going to steward your data anymore. We are. There's issues with replication and all kinds of other issues. What we've done in the USGS is we've created this community for data integration. The thing I want to stress, and this is really important when you're dealing with scientists, is this wasn't mandated, this was volunteers. So I flipped it on its head and said, okay, how can we create a community that helps solve your problem, the problems that you're dealing with? These are operational practitioners that have real problems every day, accessing the kind of data that they want to access, communicating it, visualizing it. So we have this community now chartered with over 500 members. We talked a lot about in the last day and a half about incentives. How do you incentivize a group like this? Well, I've taken some money off the top of my organization, and I annually have a competitive process where I fund projects that are submitted to me by this community. And this is after the community has vetted them and discussed, you know, ones that have the highest value. So what kind of projects am I looking for? Ones that are really focused on solving a short-term science challenge. So in other words, when this is done, there'll be a tangible benefit that can be demonstrated. That it leverages an existing capability already in the organization, that it takes us in a direction toward creating a sustainable infrastructure or creating a methodology that can be replicated across program or across area. Something that exposes corporate data that we have that's incredibly valuable to the external community. So I've got a set of criteria, and I've got a real rich community that it's really interesting how the community supports themselves in this as well. There's a lot of stealing shamelessly ideas that others have, sharing of their data and their infrastructure. One just quick mention at one of the things that we're doing associated with the science strategy at USGS is we've created this virtual center called the John Wesley Powell Center for Synthesis and Analysis. And one of the things this community does is it tries out, it prototypes a lot of the things that we're doing on real problems that are brought to us by this science entity that's got this big challenge of synthesizing data. So we've got to use it as an incubator and a test bed. And we're also working with a lot of partners. So one of the things I wanted to stress here is that you too can be a member of the USGS community for data integration, and I'd be very happy if you went out, if you could just Google it if you want USGS community for data integration, but there's the link there at the bottom. We welcome all comers because we recognize that in order to get our science done, it's not just the data that we have at USGS, but working with folks from other federal agencies, state, local, nonprofits, everybody. So now to get to the point of one of the points I wanted to make back here is this is more than just a loose group of folks. One of the things I really wanted, this third bullet, is I wanted them unified behind a long-term vision, but I really didn't want to prescribe that vision from the top. So after we had a couple of years under our belt of doing some great projects that solved some of their issues, then I asked them to take on this issue of the enterprise. What is the data integration framework that we're working toward? Once we have that in place, let's fund the kind of projects that we know are working toward where we want to get. So they named it the Science Support Framework, which I thought was great, recognizing that it's not about information technology, but it's about the mission of the organization. It took a step back and looked at the scientific life cycle, monitoring, assessment, and research, and how it really begins shortly after hypothesis with, collection of data, interpretation of that data into information and knowledge. And they really wanted to marry up what we are doing here with data integration with the key steps that involve the sciences. And so they came up with these categories of areas that we need to address. Data information, data and information assets, computational tools and services, management policy and standards, and all of that, embedded in a community of practice. So this is the framework that we're shooting for, and our belief is that if we're making progress along these lines under data of improving the persistency of our archives, registering our data in authoritative catalogs with metadata, if we're putting in place the kind of web services and data discovery tools and infrastructure, if we're supporting our scientists through training, through the data management lifecycle, a lot of this is about educating our scientists so that they understand, and I think we talked about this a little bit in the last day and a half, that at the very inception of their project, they understand how this data is going to ultimately be used and curated through its life cycle. So these are kind of the pillars of this science support framework. From the bottom, looking at the beginning, monitoring assessment through data, through transformation into information and knowledge. And these are the kind of key areas. This is scientific data lifecycle processes right here with the data lifecycle layered over it. And what we've done now is, moving just forward a couple of slides, is we've taken each one of the major projects that we're working on in the areas that we're funding and tied them back to a spot in the frameworks to demonstrate how, as we move forward, we'll be filling out the framework and collectively working in a common direction of where we need to get to. So I want to talk a little bit about the kinds of examples of the kind of things that we're looking at and why we're looking at them. So the first one, the USGS is very well known, I think historically well known for our long-term data sets. Everything from our bird banding, annual breeding bird survey, to, in this case, the National Water Information System, which in some cases has over 150 years of continuous record of monitoring for stream gauges in terms of quantity and quality of water. You can imagine how much data that is. There's over 900 different kinds of water samples in this database, and some of the sensors that are in the field provide data on every 60 seconds or 5-minute cycles over years and years and years. To query this data, to even know what you're looking for, you have to be an expert. So how do I go to a biologist who's really interested in water quality information? How do they wade through these volumes and volumes and volumes of data? So this was a concerted effort by the community, as well as a lot of credit goes to the water mission area in the leadership of the water informations team, to put a web service, build a service-oriented architecture on the back end of a legacy system that has all this data in it, so that this data could be advertised through web services. And then the community came together and built a front end to that was web-based, open source software, could be distributed, and which we have done is released it to the world through open source, that allows anybody to basically go in and very quickly do a query of a geographic area and quickly identify the kinds of water monitoring issues they're interested in and get the data back and get it back in a format that I can download and use it. Second piece that the community worked on and delivered is this data upload and registry and access tool. This was specifically for much smaller projects, the other end of the spectrum, individual scientists or a handful of PIs that work on data that doesn't have a big corporate database in the sky, a home to go into where it can be properly curated and metadata can be added to it. So this tool was built to allow USGS scientists to take their personal data and load it up to a corporate repository where it can then be made visible and be accessed. This is a mobile applications framework that the community's put together which is a framework that allows practicing scientists as well as their IT support staff that may not be familiar with all of the ways in which mobile devices can be configured. This gives them a pathway and a suite of tools that allows them to configure those in a way that's consistent with where we want to go in terms of data integration. Semantic, we're kind of tiptoeing into this world of the semantic web, and we've got, in this case, a set of scientists and data practitioners benchmarking and testing a particular scientific discipline and the use of semantic and ontological web, kind of the forefront of what's coming out on the web and how that can be used to make USGS data more usable. We put together a data management website that encapsulates the policy that we're going to be putting out in fundamental science practices. One of the things that is has been historically a strong point of the USGS is our commitment to a suite of fundamental science practices that address issues like peer review and publishing. So we're incorporating data management into that policy this year and rolling out an accompanying website that has the kind of tools that assist scientists in complying with that policy. And the last thing I'm going to point out is this project, which was essentially what we refer to as a big data broker, but a tool that allowed some of our climate scientists to access big data from downscaled modeling efforts and integrate them in a way that the output from one model can be cleanly fed into the input of the next model without a whole lot of extraction, transformation, and load and difficulty data cleaning processes. So just real quickly, working right across the board here from accessing our corporate data to giving a home to some of our orphan data, to getting our organization into the mobile world, getting it into the semantic world, recognizing that our scientists need help and tools and training in this data management area, and working along the lines of big data are some of the initiatives that we've been able to push really from a grassroots level in a community of practice. And I think this notion of community is we've been at it now within the USGS for about 5 years, but we're really now trying to reach out to, I was speaking on Wednesday with the Earth Science Information Partners. We're really trying to reach out to the other communities of practice that are out there and other organizations and other disciplines. And I think that sense of community operational practitioners that have similar challenges, that's going to be a big way that we move forward as a community to make data integration a reality. So I thank you for your time. I think I'm still yellow. I just want to take credit for that. And
thank you, Kevin.
Take questions.